Okay, so again, thank you for the nice introduction and also all of you for coming. I don't need to introduce myself anymore because you did a great job, so thank you. My name is Michael, and today I will be talking about teaching what we practice, open science in higher education. And the focus of this talk will be based on my experience on how we can actually teach open science practices in higher education. So at the university level, how can we actually convey the message that open science is something to do when we teach that in seminars and lectures, and also when students have to do their thesis, for example, in the bachelor or master thesis. So this is the focus of my presentation today. And I centered the idea of this presentation around climbing a mountain. So the 5 steps that I developed over the last 5 years, teaching open science as part of research-oriented seminars, are symbolic of climbing the open science mountain. So this is my proposal on how to use open science in higher education, 5 steps to climb the open science mountain in higher education teaching. So the first step would be that we need to make students conscious about the status quo in research that concerns psychology, management, but also sustainability and organizational science. And that status quo is that some of those studies can't be replicated or are hard to replicate. So this is the first step that we need to make students, in my opinion at least, aware of. Based on that, what I do with my students at least is that they learn how to critically evaluate research. So basically being able to distinguish between those studies that are easy or good to replicate and those studies that are hard to replicate. And I think that's a skill that students can learn in university or specifically in research-oriented seminars. And based on that consciousness and based on that learning on how to evaluate critically evaluate research, what I then propose is then inform that open science might be one means to an end, and that you can actually conduct research that is or that can be replicated, and that also answers some of the questions when you ask yourself how to critically evaluate that research. And based on that, being introduced and being informed about open science, the fourth step then will be to actually mobilize students to engage with open science in a guided way. At least that's my proposal, and that's what I did in the past. I, for example, use open science principles or practices, for example, the pre-registration in one of my research-oriented seminars, and then guide students through the whole process of conducting or writing a pre-registration. And based on that mobilization, so if students are mobilized, I think it also helps to talk about or beware of the fact that there are still some pitfalls in open science practices, but there are still some benefits that may outweigh, and at least in my opinion, outweigh the pitfalls that you come across. And based on those 5 steps, I hope it's doable to achieve the top of the mountain, so to speak, so to climb the higher education open science mountain that we have in front of us. At least that's what I tell my students, that this way it's quite easy to climb the mountain. So what's behind the first step? The first step would be to make students conscious about the status quo in research. So to make them aware that even though open science has been around for quite some time, at least in psychology, for the last 10 years at least, there are still some obstacles, especially in management and other related fields. So a lot of fun research, which is the hard truth, are hard to replicate. So there's this fun study, at least I found that study to be funny, is that once you adopt power poses, for example, the Wonder Woman pose that you see in the picture, once you adopt those poses, you feel more powerful, but also that poses or these poses have an impact on your hormone levels. So for example, the stress hormone cortisol is reduced once you adopt those power poses. However, even though it's very interesting and that paper got cited a lot, we learned that that study actually is quite hard to replicate, especially considering the impact on the hormonal level in a person. A similar study that also got cited a lot, and actually a lot of policymakers try to make use of that study, is that when you have a self-report to fill in, for example, when you think about donating your blood, because I did my PhD on that, you need to fill in 30 questions, roughly 30 questions about yourself. And what they found was that if they make you sign at the beginning that everything that you subsequently fill in is truthful, that you are more likely to give your real estimates regarding the questions, which are from time to time quite sensitive, compared to when you sign at the bottom of the questionnaire. So after you have filled in everything, you sign that you answered everything truthfully. Signing at the top makes you more truthful, makes you more honest. However, again, over time, we learned that that study also couldn't be replicated. And even the authors retracted that paper. So a lot of the fun results that we had in the past and that we built previous research on are very hard to replicate. And that is due to a lack of transparency, for example, or a lack of information provided in the paper. So based on the information in the paper, it might be very hard to replicate that paper, but also based on transparency issues. For example, whether they were transparent about who they gave the question to or who they excluded from the further analysis, it made these studies very hard to replicate. So basically, my first takeaway for students and also then for teaching open practices or open science practices in higher education is to make students conscious about the fact that there are still some obstacles in research, that some studies are indeed hard to replicate, and that one of the reasons might be that there is a lack of transparency or that there is a lack of information in those studies that make it hard for you to replicate those studies. So the first step would be make students conscious about the fact that there is still some hardship around replicating studies. And once students, I think, are aware of that, it's quite useful for them then to decide which study, when they have a study in front of them, is replicable and which study is not actually, which they can't really replicate. So I think they need to learn how to critically evaluate the research that they have in front of them. And what I do with my students then is I give them a paper or they see a paper for themselves, and then they're asked to globally reflect on the paper. For example, they're just asked, what did you like about the paper? What's your general impression of the paper? What was missing or what was unclear in the paper? Or how transparent do you think the paper was? Was there any kind of information that you would have liked to be in the paper or that you thought that shouldn't be in the paper, for example? And also relatedly, when they stumbled upon the papers themselves, whether they found studies that actually did something similar, finding similar effects, or whether they are actually replications, direct or conceptual replications of the study that they are currently looking at. And based on these very broad questions, we discuss that article in class. So everyone has an opinion on the paper when he or she reads the paper. And the idea is that actually students can reflect on that paper and develop a habit of dissecting a paper. And maybe that first initial reaction is just a gut reaction, but I think it's helpful to then base that further analysis of the paper on that initial gut reaction and then come up with questions or statements to back up that initial reaction. So based on that, what I do with the students is also that I think it's then important to reflect the paper on a more deeper level. So what I did was based on previous research and based on Pennington and also on the ZBW to group some of the questions that should be able, if you answer them and when they provide answers in their paper of, that they should be able to replicate around 5 areas that follow or aligned with the classical structure of a research paper. So the first area that I discuss with the students is the theory or the theoretical background. So I ask students whether they know what the aim of the study is. And it might sound very easy, But at the same time, sometimes it's very hard to pinpoint what the exact aim or aims of the study are. And I think if the aim is quite obvious, then it helps to actually understand the paper in a more deeper level. Similarly, when the authors formulated a research question, is that research question crystal clear? Do you understand what the research question is? And most importantly, when they also formulate subsequently hypotheses, are the hypotheses aligned with the research question? So basically, do the hypotheses help to answer the overarching research question that authors posed in that paper? And to basically critically reflect the theory, you also need to know whether the constructs or whether the theoretical framework is clearly developed in the sense that everything is defined specifically. So you know that when the authors are talking about happiness, for example, which is a field I'm also interested in, whether that actually they are talking about happiness. For example, in happiness research, what you find is that there is this umbrella term called the good life, and that good life can then be divided into subdimensions. For example, there's this hedonic happiness, so whether people feel good versus they feel bad, or whether they have the purpose, which is then the second dimension, whether they have a clear direction about where their life is going, for example, or whether they feel that they are part of something bigger than their own life. That would be a meaningful life, or whether they are talking about psychological richness, so whether they are talking about a life that is characterized by perspective change. So the basic point is whether everything that is theory or theoretical driven in the introduction part or the theoretical background is clearly articulated and whether that actually is clearly defined and based on previous research. If that is the case, and if you answered everything regarding the theoretical part, you can move on to the methodological part, which then revolves around the design. So basically, whether you understand the research design that the authors actually employed. So for example, if they employed a survey, do you understand that they actually did a survey compared to an experiment? If they used an experiment, and they argue that they used a 2x2 design, do you really understand what the 2x2 design is? So do the authors really talk about what the two independent variables are and which levels those two independent variables actually have? And I think quite critically important, especially in the recent times, is do the authors clearly articulate what their sample is? So who are their participants? Is this a convenient sample? So are these university students? Is it a representative sample for the general population? Is it an Eastern sample or a Western sample? Or is it a diverse sample? I think authors increasingly notice that it's quite important to actually not to study on males and females, but also include those people who are in between, for example. And critically important is also whether the authors provide any information regarding the sample size. So usually in the past, not usually, but from time to time in the past, you had studies that conducted their analysis based on 20, 30, or maybe 35, 40 participants. And that was all that they had. And now we learned that there is something called power analysis, meaning that you can actually, before you conduct a study, calculate how many participants you need in order to find a specific effect that you're looking for. And here it is important or interesting to know whether the authors just randomly collected the data or whether they have a rationale for how many participants they aimed for and then how many participants ended up in their final analysis. It could also be that they are conducting a field experiment, meaning that the sample size is quite hard then to achieve. But the point here is whether they are upfront about the rationale for the sample size that they have. Based on the design, moving on to the variable section, it is critically important that the paper, at least from an understanding point of view for students, but also for researchers as well, is that they're very clear about what the independent variable is. So the one that is usually being manipulated is the independent variable. But what I found is with discussions with my students is that while it's quite obvious in a research question what the independent variable is, it's quite hard then to understand how they operationalized this independent variable in the method section. So it's very hard for students to pinpoint the operationalization of this independent variable in the method section of the paper. And that is also maybe sometimes at least due to that the authors do not really provide a rationale for why they manipulated the independent variable in a certain way, or whether they base their manipulation of the independent variable based on previous research, for example. Also, what happens in the open science practice, but less so a few years ago, is that authors also disclose their material. So they openly share the manipulation of their independent variable. Everything that I just said also applies for the dependent variable. So the dependent variable is usually the variable that is either measured or observed. And are the authors upfront about how they measured the dependent variable? For example, are they clear about the anchor points from strongly disagree to strongly agree? Or whether that was a 7-point scale or 5-point scale? Or whether they adapted the original scale and reduced that scale from a 10-item scale to a 5-item scale? And is the exact wording of the scale provided in the appendix or in the paper or on the open science framework, whatever that is? But are there enough information for you to be able to replicate that study regarding the dependent variable? And this is also related to whether authors provide information on all the variables that you collected during data collection. For example, students are always quite surprised when they learn that maybe not every variable ends up in the final paper. So, for example, if you read a paper, you get the sense that it's quite obvious that there's only one independent variable and then maybe one or two, three dependent variables. But sometimes, if you look at papers in the web appendix, for example, you see that they collected a host of different variables as well. And it's then for you to decide whether you want to publish all the other variables as well, because that might change the results that you have. So being upfront about that helps in understanding the result that you gained. Based on the variables, it's also then quite important to be very open about the analysis. So basically, do authors communicate the type of analysis they use very transparently? So is it quite obvious that they use the regression analytical approach over an analysis of variance, for example? Do they provide enough information for you to understand why they did it, at least, even though you don't need to understand the statistical analysis in detail? But do they provide enough information for you to get a general gist of what they did? Also, then related, do they report effect sizes, for example, or do they provide the data that they collected and then base their analysis on? Or even more, do they actually provide the code, so the analytical code they used to analyze the data? Also, a question that needs to come up in order for you to be able to decide whether that is for you to be able to replicate the data. Then also the significance level is quite important. So basically, do they adhere to the standard threshold level of significance of 0.05? Do they use another one? If so, do they provide again a rationale for that? Or do they provide exact p-values, or do they only provide threshold levels? For example, do they only provide p-values, for example, stating it was significant because it's under 0.05, or do they provide exact p-values saying that p-value equals 0.049, for example? Also, which relates to the design and the sample size, is are authors quite open about how many people they collected in general, and then how many people they eliminated from further analysis? And do they again have a rationale for why they eliminated those people from further analysis? So were there any exclusion criteria, or were there any outliers that they then used to reduce the sample? And here, the most important thing is that they are very open about it. And then you can decide for yourself whether that makes sense or doesn't make sense. That is basically a point of view, but they need to be open for you to have that discussion. And lastly, once you read the whole paper, then I think it's always useful to ask questions whether they provide enough information, for example, on the funding that actually funded the research that they are presenting right now. For example, is it funded by a third-party organization like the Deutsche Forschungsgesellschaft, or is it by a for-profit organization which might have some stakes in the results? Or did the funding organization have anything to do with how they curated the data or how the research results are presented? That also then relates to the conflict of interest. So are there conflict of interests? Is one of the authors employed by the for-profit organization maybe, or by the non-profit organization? So basically, is there any conflict of interest that you need to know of for you to be able to objectively then get an idea about the paper in general? And then I ask always students, is there anything else that you would like to know in order for you to be very sure that you're able to replicate this study? And I think based on these questions, it's very helpful to discuss that with the students in order for them to decide whether they find that paper to be relevant, to be good, to be able to replicate in subsequent studies. So basically, step 2 is, after you are aware that some studies are not easy to replicate, how can you decide which studies are easy to replicate and which aren't? You need to form a general impression of the paper, then you need to critically reflect the paper and then look for information that's either provided or maybe not provided, and then learn about why these information or this type of information is actually not provided. So basically now we are in step 2 in climbing the open science mountain, so to speak, in university education. So based on that, I think once students are conscious about the replication crisis, once they know how to differentiate between papers that you can replicate because they provide enough information versus those who not, or who are not easy to replicate, it's easy then to introduce them to open science, to inform them about open science as one means to actually produce research that is robust in the sense that you can replicate those findings, but also that helps to answer some of the questions, or ideally all of the questions that we just went through. And then I just basically give students a short introduction about open science, so what open science generally is, that it is an umbrella term for any inquiry in scientific knowledge that is transparent, credible, open, accessible, and basically reproducible. And after students get an idea about what open science is, I introduce them to open science practices. And here are some of them that I actually use with my students. So whenever students are part of a seminar that is research oriented, they have to pre-register their study. They don't have to do that online, but they have to fill in a pre-registration. And I always describe that similar to a cookbook. So before you actually cook the meal, you basically see a recipe, you need the ingredients, you need to know the step that you need to follow, and you can't really do step 10 before you did step 1. So it doesn't make sense to eat the pasta without boiling it first. So basically, pre-registration is similar to a cookbook. And that it specifies the theoretical background, the variables, the type of analysis, but also then how you want to present your data. Another way, so after you collected your data, another badge that you can earn if you adhere to the open science practices is open data, meaning that you give your data to the general public, make it accessible to everyone who is interested, and they can reanalyze your data, use your data for meta-analysis or whatever the reason, but you are very transparent about the data that you used. Another thing is open materials, and that alludes to some of the aspects also that we discussed in the questions. For example, whether you publish your stimulus. So basically, the open science badge of open materials just means whether you are very open about the stimulus material and provide enough information, for example, about the independent variable. Another thing is open access, that you don't publish only behind a paywall, meaning that you need to pay in order to access the article that you publish or want to publish, but instead make it accessible for the general public. And then there are also practices that are called many-lab or multi-site projects. And these projects basically are just a bunch of researchers, oftentimes from different parts of the world, trying to answer one research question together, combined, conducting data or collecting data in their home country, and then combining the data to analyze and get a whole picture to answer that research question. And once students know that, I think the next step then is to link the open science and how that can help basically with the replication crisis, because it was one answer to the replication crisis. So the study from the beginning, basically around the power poses, turns out they are quite powerful, but not that powerful. And during a large replication study, they also adhered to the open data and open materials and used a larger sample than the original study, found that while there might be some truth to that, the impact on the hormones that the original study found actually can't be replicated. So it helps actually to bring some clarity to studies that we had conducted in the past. Also, maybe those open science badges are quite good and quite easy to understand, but maybe not all journals use those studies. So it's quite useful to actually go into the abstract or in the method part of the study and then see how they conducted the study. And here you can see that in the abstract, it's mentioned that it's one highly powered pre-registered direct replication. So the original author of the study of signing at the beginning basically replicated or tried to replicate their study using a larger sample and then failing to replicate their results, leading to the fact that they published actually a paper saying that their original results can't be replicated using a larger sample. So I think that helps then students to actually make the connections between the replication crisis, the questions that we discussed in the second step, and then link that to the open science as one means to basically counter the replication crisis. And I also tell students that even though some studies do not have those badges, there might still be awesome papers. For example, if you look at the methods parts, there are a lot of studies now, especially in psychology, that conduct power analysis. So before they run their study, they calculate how many participants they need to be able to find a specific effect. And that doesn't necessarily mean that they have the open science badge, but still they adhere to open science practices. Similarly, there are, at least to my knowledge, not really badges on disclosure of funding, for example. But here you can see that they received some funding, and that funding did not influence, at least to their statement, the data collection, the analysis, the interpretation of the data, nor the decision to submit the article for publication or to a specific journal. And lastly, despite not having any badges, there still might some headlines be in the paper about open practices where they are openly sharing their data, their syntax, or their code for analysis. So it's very important that students not only know about the badges, but also then learn how to look into the paper and then decide whether they adhere to open science principles. And based on that, I think the takeaway message for my students, at least then, is that they need to be informed about what open science means. So basically give the definition, then look whether they find open science badges. In case they don't need to necessarily disregard the paper as a whole, but then look into the methodological part of the paper and then see whether there actually is information provided that helps them to understand at least, or there are some rationales for why the authors made certain decisions. Like I said, despite not having badges, they can still adhere to open science principles and it could still be a great paper. So based on being conscious, then learning about how to reflect the paper, then being informed about open science, we are halfway through climbing the open science mountain. The fourth step would actually be directed towards the teaching side. So then I think once you introduce students to open science, it makes sense to mobilize them to actually engage with open science, to actually do some or experience some open science practices. And here, what we did was my colleague of mine at Leuphana University actually developed some videos, for example, introducing students to the notion of open science, so defining open science, but also going through a pre-registration or a registered report or sharing your data or code, for example, your analysis code for others to see. So I think providing as a first step students with resources that they can use to familiarize themselves with open science is quite useful. And as mentioned in the introduction, I'm also the lab manager for the Leuphana Laboratories, and we have a small section on the webpage from the Leuphana Laboratories mentioning open science and transparency in open science. And there we link the YouTube videos that we developed to introduce students to open science. And then after you provide resources, I think it's quite useful then to integrate open science per se into teaching. And I think the easiest way, at least from my point of view, is to include open science into research-oriented seminars, so studies in which students have to conduct an empirical study themselves, whether that is an experiment, like in my studies or in my seminars, or a survey, or whatever that is, or a qualitative study. But I think that's the easiest way. And here's a syllabus of a study or of a seminar that I actually teach each winter term, and it's roughly based on the structure of a pre-registration and based on the steps that I just introduced. So first of all, we talk about the theoretical background. So we take a paper and then dissect the paper, whatever the paper is. But I ask students about globally reflecting the paper, then reflecting that on a deeper level. We talk about the methodological approach, and then also students have to fill in a pre-registration before they collect their data for their study. And I think it helps them to think everything through, and it helps me to guide them. So basically, not to forget anything or make them aware that there are still some parts that are missing or still some part they need to think of. And another thing where I apply open science practices are in my guidance of thesis. So, for example, if students write a bachelor thesis or math thesis, there usually is a kickoff. Then they find a topic that they're interested in. And then from that point on, they need to bring in the pre-registration digitally at least, and then fill that in subsequently. So before they collect the data, each session that we meet or each appointment that we have is designated to a few blocks in the pre-registration, so they actually get guidance on how to fill it in, but also think everything through before they collect the data. And one day or one evening at least before they start with the data collection, they have to hand in the pre-registration with me, and then they are free to collect the data the way that we decided in the pre-registration that they will do. And then they collect the data, they analyze the data. In case they have questions, they can come to me, and then we will discuss those questions. And then they have to hand in their thesis, write the report, and then also hand in their data as well as the materials that they used in their study. So basically, the whole process of writing a thesis can be implemented that is particularly in line with the open science practices. And I think now 3 years ago, I developed one workbook that I use in my research-oriented seminars, but also during my bachelor thesis. And it started as a workbook on just conducting research, but similarly to the syllabus that you saw here, the agenda of the workbook is loosely based on the pre-registration. So again, we talk about the construction of the paper, then we talk about the methodological part, and then also there's some guidance on how to fill in a pre-registration. And what they do is hopefully, at least I hope that, they fill in the workbook at home, and then we discuss everything that they filled in class. So basically we can discuss open questions or everything that is unclear. And as one example, I provide a commented version of the pre-registration in the workbook with the idea in mind that that helps students to actually fill in the pre-registration themselves. Because I think the first pre-registration that you have to fill in is quite hard. You're quite unsure about what to do. And hopefully that helps students to actually fill in their pre-registration. So that's basically step 4, mobilizing students to engage with open science. So you need to find resources, so videos similar to my workbook, which I'm happy to share in case you want to take a look at that. And then include open science into your teaching, and then just see what works best for your students or for your research project, and then adapt the process. The last step is actually the final step to climb onto the top of the mountain, basically, is that I think it's also for teachers, but also for students upfront, good to know that there are some pitfalls, but their pitfalls are not outweighed by the benefits. But you need to be aware of the pitfalls and benefits. At least I think so. So I think generally, if you compare conducting open science with no open science, for example, conducting a pre-registration with not conducting a pre-registration, I think it usually is more work. At least that's what my students tell me, that it is more work to fill in a pre-registration. At the same time, they also acknowledge that afterwards it made everything more clear or clearer than they anticipated before. But also, it's a lot of more work for teachers in case you want to give feedback on the pre-registration or evaluate the pre-registration, which is also kind of tricky because I think the level of disclosure that you put into the pre-registration kind of varies. So it could be that you're very specific or that you're very vague, but it's not either good or bad. It highly depends on the study that you are conducting. And I also think when you evaluate a pre-registration, for example, it's helpful to notice that students do it for the first time. So I think if I think back to my first pre-registration, it might not be the best that I've written, and I think it's good to keep that in mind that students are there to learn. Having said that, I think the benefits outweigh the pitfalls. So I think it's great to structure research-oriented seminars. It's great for guiding supervision, and similar to what mentioned or what was mentioned in the introduction, I think it's also quite trendy or quite on vogue with students because they are generally very much open-minded regarding open science. They have a tendency to react in a way that suggests they don't understand why that hasn't been the norm for the last 40, 50 years. So the takeaway here would be, even though it can mean a lot of work, it can help structure your research-oriented seminars, and students are interested in open science anyway. So summarizing what I talked about for the last 30 minutes is we need to make students conscious about the status quo, meaning that there is, even if you think there is not a replication crisis, there's a replication problem. At least we need to acknowledge that and make students aware of that. We also need to make students learn how to evaluate papers that they have in front of them. Otherwise, it's very hard for them then to decide whether something can be replicated or something can't be replicated. Then also, it's useful then to inform students about open science, even though they know about the idea, maybe they don't know about the different open science practices that you can employ. 4, you need to mobilize students to use open science. I think the first reaction would be, yes, it's cool if you read it in a paper, but it's also a lot of work. Maybe we shouldn't do it. But then they actually are quite open and quite enthusiastic about using that. And lastly, you need to make students, I think, aware that even though it means more work, it's maybe better work if you adhere to the open science principles. And I think that way you can climb the open science mountain. And that was it from my side. So thank you very much. And in case you want to know about the workbook and take a look at the workbook, I'm happy to share what I did.